Section 7.2, inverse trigonometric functions. It's a continuation of the previous section, basically. What do we have here in this section? First thing I want to recall, because we're going to be using this all the time, that sine inverse of x always from negative pi over 2 to pi over 2. Cosine inverse 0 to pi. And tan inverse, because we're going to need this all the time, between negative pi over 2 to pi over 2. I'll start with an example because it's a continuation from the previous section. So let's say we're asked to find the value of cosine tangent inverse of 1/3 without using calculator. So how do we start with this one? We always take the quantity inside the parentheses to equal to any letter you like, A, alpha, beta, whatever you like. So let alpha equals negative 1, tan inverse 1/3, tan inverse 1/3. And by definition, this is tan alpha. This means tan alpha is 1/3. Remember, this is alpha. It's tan inverse. And do you see the condition here? So alpha between negative pi over 2 to pi over 2. Okay, so alpha this is negative pi over 2 to pi over 2. So it's somewhere here. But notice the tangent I found here, the tangent is positive. But tangent is positive only in the second quadrant, not the fourth quadrant. So this means from these two together, we can say that alpha is specifically in the first quadrant. So now what am I trying to find? I'm trying to find cosine. So I want to find cosine tangent inverse of 1/3. So this is cosine alpha, because we assume this is alpha. So how am I going to find cosine alpha? Notice I do the Pythagorean theorem on the triangle. From this, tangent is by SOHCAHTOA, assume this is alpha, is the opposite over adjacent. So then that gives me, by the Pythagorean theorem, 9 plus 1 is 10. So then I need cosine alpha. From here, cosine is the adjacent over the hypotenuse. And we would like always to see that students are rationalizing the denominator. So that gives me 3 squared of 10 over 10. One thing to pay attention to is the sign of the answer. Is it positive or negative? Well, I'm finding cosine alpha. And remember, we said alpha falls in the first quadrant. So that means it's positive. All the angles in the first quadrant are positive. Let's look at another example. Find the value of cosine sine inverse of negative 1 over 6. Well, again, we assume this is alpha. Let alpha be the sine inverse of negative 1 over 6. Negative 1 over 6. And we know that sine inverse, which is alpha, is from exactly negative pi over 2 to pi over 2. So I have it in the quadrant 4 and quadrant 1. So here. Okay, so in these two quadrants. So what do we need to find out? We need to get cosine sine inverse of negative 1 over 6, which I assumed it's alpha. So what is cosine alpha? Well, I need to find using the Pythagorean theorem. Well, from here we can say sine alpha is negative 1/6. Negative 1/6, and alpha from negative pi over 2 to pi over 2. That forces alpha to be only in the fourth quadrant. It can't be in the first, because in the first it's positive. See, this is negative. So this forces alpha to be somewhere from negative pi over 2 to 0. Right? It can be 0, because sine 0 is 0. So I'm in the fourth quadrant working. So what does that give me here? From this, forget about the negative sign. Sine is the opposite over the hypotenuse. So by the Pythagorean theorem, 36 minus 1, 35. So cosine is the adjacent over the hypotenuse. And it should be positive because it's in the fourth quadrant. In the fourth quadrant, cosine is always positive in the fourth quadrant. Let's look at another example similar to this. Find the value of tan or tangent sine inverse of negative 2/3. So again, the key is to start by let alpha equal sine inverse of negative 2/3. So by definition, or this means sine alpha is negative 2/3. Keep in mind it's negative here. And we know since I took alpha equals sine inverse, alpha must be between negative pi over 2 to pi over 2. So I'm in the fourth and first, but since alpha was negative means we are in the fourth quadrant only, and we need the triangle. Some people do it on the circle. I just do it on the triangle, easier. Sine is the opposite over the hypotenuse, so this would be 9 minus 4, which is the square root of 5 by the Pythagorean theorem. So again, from here alpha is forced to be from negative pi over 2 to 0. What all I want to find is that one. That's tangent alpha now. So tan alpha. What is tan alpha? Is the opposite over adjacent. And we need to multiply by the conjugate. So that gives me 2 square root of 5 over 5. Again, always look at it. We are in the fourth quadrant. That's where alpha is. Tangent is negative in that quadrant. Don't forget the negative sign. Very important. So that was some quick applications about tangent inverse, cosine inverse, and sine inverse. What about the other 3 trigonometric inverse functions? Let's list them under definitions. The first one, y equals secant inverse of x. This means, as we did before in the other functions, x equals secant y. And what are the conditions on x and y for this one? X must be from 1 on, if you remember how the graph of secant inverse looks like, or at least secant. It was above from 1 on and negative 1 down. That can be rewritten like this. The absolute value of x bigger than or equal to 1. And for the y, it's in the first and second quadrant, provided y cannot be pi over 2. See, secant is 1 over cosine, so cosine was from 0 to pi. The next one is y equals cosecant inverse of x. That means x equals cosecant of y. Again, the condition on x is the same, but the y is different. Secant is 1 over sine, cosecant 1 over sine, and it was from negative pi over 2 to pi over 2, but y cannot be 0. Like y cannot be the middle point between them. Number 3, y equals cotan inverse of x. This means x equals cotangent of y. X here is from negative infinity to infinity, and y is from 0 to pi, excluding the bounds. Those are the definitions of those 3 trigonometric inverse identities or functions. How do we apply them? Quick, easy examples. Find the value. Find the value of, let's say, secant inverse of 2. Secant inverse of 2. How do we start with this one? Let's say it's alpha. Call it alpha. By the definition, this means secant alpha is 2. So it's like, what is the function is secant is 2, or what's the angle is secant is 2. Keep in mind, secant inverse, remember y, the secant inverse, from 0 to pi. So alpha is from 0 to pi, but it can't be pi over 2. Alpha cannot be pi over 2. From here, if I want to find what that is, this is equivalent to say that cosine alpha is 1/2. If you flip both sides, 1 over secant is cosine. What are the values of alpha, or value of alpha? From 0 to pi, excluding pi over 2, it's cosine 1/2. Well, there is only one alpha value, let's call it, in the interval 0 to pi, so that its cosine alpha is 1/2. Or in other words, its secant alpha is 2. And this alpha here is 60 degrees, or pi over 3 radians. That's the answer. Another slightly different example. Sometimes they can ask us to write cosine tan inverse of x as an algebraic expression. An algebraic expression containing x. So what do we do with this? We start with the inside. We let alpha, as we did earlier, as tangent inverse. But what do you know about alpha for tan inverse? It's from negative pi over 2 to pi over 2. And if you like, the x from 0, negative into infinity. So from here, this means tangent alpha is x. And when I say x, I mean x over 1. We mean x over 1. So what are we kind of asked to find? Cosine tan inverse. So cosine tan inverse. This is cosine. Tan inverse is alpha. And how do I find cosine alpha? Well, let's see. First thing, I'm working in here. Negative pi over 2 to pi over 2. Okay. From this, I can construct the table. I mean the right triangle. Alpha. Tangent opposite over adjacent. So this is 1 plus x squared. Cosine alpha. Cosine is the adjacent over the hypotenuse. Adjacent over the hypotenuse. So that's all we have. Now, is it plus or minus? Well, in the first quadrant and the fourth quadrant, cosine is positive in both of them. So that's why it's just positive. We keep it as is. So what I was able to find an expression in x. Algebraic, we call it algebraic expressions in x. Okay. Same, let's try to do same for cosine secant inverse of x. They all follow the same procedure. Let alpha equal secant inverse of x. This means secant alpha is x. X means x over 1. Okay, x over 1. What is the question asking? Well, make sure you put the conditions on alpha. 0 to pi, but alpha cannot be pi over 2. It can be pi over 2. And the opposite value of x must be bigger or equal to 1. So what they ask us to find? I assume this is alpha. So that becomes cosine alpha. What is cosine alpha? Wait, cosine, and I have secant. I don't even need the right triangle. This is 1 over secant alpha. And secant alpha is x. So the answer is 1 over x. So this is how we convert or write those trigonometric expressions as algebraic expressions in the variable x. So this was a short section because it was just a continuation of the previous section. Not a lot of additional like concepts to know, just quick definitions were introduced here. And based on the example that we saw here, all the examples, no matter how they change them, you will get the same procedure, the same thing. Either cosine alpha is 1/2, or sine alpha is 1/2, or rad square root of 2/2, or square root of 3/2, or something we are familiar with, 1, 0, -1, these things. And then you should be able to find all the alpha values within that interval. In this case was 0 to pi. That would satisfy this equation. That's what this section is meant to be, just a continuation of the previous section. So not a lot of concepts, new concepts introduced in here.